So today in class we looked at number 5 from homework set 2, and for part B I had something in mind I wanted to do, and I know there's lots of ways to do all these, but I don't think well, the way I was thinking didn't match up with what we did in class, but that's totally fine. But I thought I would go through what I was thinking. So part A I think is fairly nice, and this would be a typical, I think, test type of problem. You have 2 white marbles, 3 red, and 5 blue, and you're going to pull these out of an urn, and you want all the different kinds of arrangements of the marbles. And the whites are indistinguishable from each other, the reds and the blues. So since you have 10 total marbles, there's 10 factorial ways to arrange them, but since you can't tell a blue from a blue or a red from a red, I have to divide out the number of ways I can rearrange the whites, which is 2 factorial, times reds 3 factorial, times blues 5 factorial. Okay, so there's part A, a nice little warm-up exercise. In part B, I guess I like to still break things into cases. I'm figuring out the number of ways that the blue marbles can be in positions 2, 4, 8, and 10. And I thought, well, I'm going to condition, how many I'm going to have for the second, fourth, eighth, and tens depends on if I put a blue in the first slot or not. And I realized, like in class today, you don't have to. It's sometimes just the way, you start and think of the problem. So for case number 1, let's put, I'm going to put a blue in slot 1. Okay, so I have these 10 slots for the marbles. 1, 2, 3, 4, 5, 6, 8, 9, 10. So if I put a blue in slot 1, right now there's 5 blues, so I have 5 choices for that blue to go in the first slot. So here's the second slot, 4th slot, 8th slot, and 10th slot. So when we come to the second slot, I have 4 choices for a blue now. 3 here, 2 here, and 1 here. So now the only thing I have to worry about is the number of ways to rearrange the other marbles. So I can put the reds and the whites anywhere in these other slots. So I have 5 choices for the others, 4, 3, 2, and 1. So I end up with, if I have a blue in slot 1, the number of ways I can do it with the blue starting out is 5 factorial times 5 factorial. And then I still have to divide out identical blues and reds. So 2 factorial times 3 factorial times 5 factorial. So I guess in the end, I mean, the blues don't matter at all, like somebody said in class. All that matters is how to rearrange those other marbles around the blues. And so here, what did I end up getting? I feel like I got 10. Yeah, that should be 10, so this should just be 10. And so I looked at case 2, which is I didn't put a blue in the first slot. So case 2, no blue in slot 1. So here's my 10 slots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm not going to put a blue here, so in slots 2, 4, 8, and 10, I have 5 choices for a blue here. I have 4 choices, 3 and 2. And then I said there's not going to be a blue here, so the number of choices I have for the first slot here is actually 5, right? Because I have 5 of the whites and the reds. And then when I get to this slot right here, I still have 5 marbles left. So 5, 4, 3, 2, and 1. So this turns out to be 5 factorial times 5 factorial times 5 over 2 factorial, 3 factorial, 5 factorial. So the 5s go, and so I have pretty much 10 what I had before. So this time I have 50. So together, right, so that's 10. So there were 60 total ways such that the second, fourth, eighth, and 10 marbles are blue. So totally I got 60. And I think I'll go ahead and cut this before I make part C so it doesn't get too long.